There's something about the quiet hours after midnight, when our minds wander into territory that daylight seems to discourage. In these liminal moments when the world has settled into stillness and consciousness floats freely between waking and dreaming, we find ourselves confronting questions that feel both impossibly vast and intimately personal. Tonight, we'll explore one such question, perhaps the most fascinating mystery our species has ever stumbled upon. The simulation hypothesis emerges from that peculiar intersection where cutting-edge physics meets ancient philosophical doubt. Unlike previous generations who wondered if life was a dream, we're the first to ask if reality might be computational, a question that feels both absurdly modern and timelessly human. This isn't just philosophical speculation anymore. It's a serious consideration among physicists, philosophers, and technologists who've begun to see digital fingerprints in the fabric of reality itself. Consider the strangeness of our moment in history. We've developed mathematics sophisticated enough to describe the universe's behavior with extraordinary precision. Yet the deeper we probe, the more reality resembles the kind of system a cosmic programmer might design. Energy comes in discrete packets, space and time have apparent resolution limits, and information seems to be the universe's fundamental currency. These aren't the smooth, continuous phenomena we might expect from a purely natural reality. Perhaps what makes this question so compelling isn't its technological dressing, but how it captures something we've always sensed, that reality feels simultaneously solid and ephemeral, detailed beyond comprehension yet somehow constructed. When we observe the elegant mathematical laws that govern everything from quantum particles to galactic clusters, we're witnessing either the most remarkable coincidence imaginable, or evidence of intentional design by minds far more sophisticated than our own. And so we find ourselves, in these quiet moments, contemplating whether the universe itself might be thinking. Our daily lives have become dress rehearsals for this very question. We're the first generation to live intimately with simulated worlds, carrying pocket universes populated by millions of digital beings, each following their programmed routines with apparent autonomy. When we observe NPCs in games going about their scripted lives, seemingly unaware of their artificial nature, we're witnessing a mirror that reflects back an unsettling possibility. We've grown comfortable inhabiting multiple realities simultaneously. Our physical world, our online personas, our gaming avatars. We switch between these different versions of ourselves with fluid ease, each one feeling authentically us within its particular context. This multiplicity of identity across different platforms has prepared us, perhaps unconsciously, to consider that our primary identity might itself exist within a simulated context. There's something profound about watching a digital sunset in a game world and feeling genuinely moved by its beauty. If artificial beauty can touch us so deeply, if programmed music can inspire real emotions, if virtual relationships can provide authentic comfort, what does that say about the nature of beauty, emotion, and connection themselves? Perhaps these qualities are more fundamental than their substrates, more essential than their origins. We've become archaeologists of artificial worlds, and perhaps, unknowingly, of our own. What began as imaginative speculation has quietly migrated into the most prestigious academic journals and conference halls. Nick Bostrom's 2003 paper didn't just propose simulation theory, it mathematically formalized it, creating a rigorous framework for considering the probability that we're living in a simulated reality. His trilemma suggests that either advanced civilizations destroy themselves before developing simulation technology, they choose not to run ancestor simulations, or we're almost certainly living in one of countless simulated reality. Elon Musk's casual assertion that we're probably living in a simulation wasn't tech bro hyperbole, but reflects a growing consensus among those who work most closely with advancing computation. The rate of improvement in graphics, AI, and virtual reality suggests that indistinguishable from reality simulations are not a matter of if, but when. Musk's billions to one odds in favor of simulation theory stem from simple extrapolation. If we can create increasingly convincing simulated realities, then more advanced civilizations could create perfect ones. Even physicists like John Wheeler began suggesting that reality might be fundamentally informational, captured in his phrase "it from bit." This idea proposes that all physical entities derive from binary choices, from bits of information rather than material substance. Wheeler's insight preceded our digital age, but anticipated its central revelation, that information might be more fundamental than matter or energy. These aren't fringe voices, but leaders in their fields treating simulation theory with the same seriousness once reserved for questions about the nature of space and time. The migration of this idea from science fiction to scientific discourse represents one of the most remarkable conceptual developments of our era. The universe, it seems, has been dropping hints all along. This isn't a journey towards certainty, but something more valuable, an exploration of possibility that enriches our relationship with existence itself. Over the next few hours, we'll explore this question not as detectives seeking proof, but as curious wanderers in a landscape of profound mystery. We'll examine the evidence that makes scientists take simulation theory seriously, from quantum mechanics' strange digital-like behavior to the mathematical patterns that seem too elegant to be accidental. We'll consider what it might mean for consciousness, for purpose, for the very nature of what we call real. We'll explore the possibility that we're created beings living within the careful attention of minds we've never met, and contemplate what that might reveal about the nature of consciousness itself. We'll examine the evidence hidden in plain sight, the quantum mechanical oddities that resemble computational shortcuts, the fine-tuning of physical constants that suggests intentional calibration, the information-theoretic foundations that seem to underlie all physical processes. But our goal isn't to solve the mystery, it's to appreciate its profound beauty and allow it to transform our sense of wonder about existence. We'll discover that whether we're biological beings who evolved through natural selection, or digital beings crafted by advanced programmers, the experience of consciousness remains equally remarkable, equally precious, equally worthy of celebration. So settle in, let your mind wander, and allow yourself to be curious about the most intimate mystery of all, the nature of the reality you're experiencing right now, in this very moment. If reality were a simulation, we might expect to find evidence of its digital nature in the deepest layers of physics, and remarkably, that's exactly what we discover when we probe the quantum realm with sufficient precision. At the quantum level, reality behaves less like the flowing, analog world we inhabit, and more like a digital system with built-in limits and discrete units. Energy comes in packets called quanta. You can have one photon or two, but never 1.5. It's as if the universe has adopted a digital currency system where everything must be purchased in exact change, where fractional transactions are simply not permitted by the underlying architecture. This quantization extends beyond energy to angular momentum, electric charge, and other fundamental properties, suggesting that discreteness rather than continuity might be reality's default state. Even more intriguingly, there appears to be a fundamental limit to how much information can be contained in any region of space, known as the holographic principle. This suggests that reality might be more like a cosmic hard drive, with finite storage capacity, than the infinite, continuous expanse our intuitions expect. The principle emerged from black hole physics, where physicists discovered that all the information contained within a black hole's volume can be encoded on its two-dimensional surface, exactly like a hologram, or perhaps like a three-dimensional scene, rendered on a computer screen. The Planck length, about 10⁻35 meters, represents another digital-like boundary that hints at reality's computation nature. Below this unimaginably tiny scale, our physics equations break down entirely, as if we've reached the resolution limit of reality itself. It's remarkably similar to what happens when you zoom too far into a digital image and begin to see individual pixels. The illusion of continuity dissolves, revealing the discrete units from which the larger picture is constructed. Even time appears to be quantized at the Planck scale, suggesting that reality might be updating in discrete frames, like a cosmic computer running at an incomprehensibly high refresh rate. Perhaps most fascinating is quantum entanglement, where particles maintain instant connections regardless of the distance separating them. Einstein called this spooky action at a distance, because it seemed to violate the principle that nothing can travel faster than light. But in a simulated reality, this wouldn't be mysterious at all. It would simply mean that entangled particles are referencing the same piece of code, the same data structure in the cosmic program. The instantaneous correlation across vast distances becomes trivially explainable if both particles are variables pointing to the same memory location in some vast computational system. The observer effect in quantum mechanics provides another computational signature. Until measured, quantum systems exist in probabilistic superpositions of all possible states. Only when observation occurs does the system collapse into a specific outcome. This resembles nothing so much as computational optimization, rather than calculating every possible detail in advance. The universe might only render specific outcomes when something needs to know the result. It's the ultimate in efficient programming, avoiding unnecessary calculations until the results become relevant to some observer. Consider this: if you were designing a universe from scratch using computational principles, you might very well implement exactly these features: energy conservation through discrete units, information storage limits to prevent infinite complexity, reference systems to maintain consistency across vast distances, and lazy evaluation to avoid wasteful calculations. The universe appears to be using the same optimization strategies that any sophisticated programmer might employ when working with finite computational resources. Reality, it seems, has been whispering its digital secrets to us all along. We just needed to learn its language. But perhaps the most profound evidence comes from mathematics itself, and the strange way it seems to be the universe's native language, rather than merely a human tool for describing natural phenomena. Physicist Max Tegmark proposed something that sounds almost mystical, but gains credibility under careful examination: that mathematical structures don't just describe reality, they are reality. In this view, what we call the physical universe is actually a self-consistent mathematical structure, playing itself out according to its own internal logic. This idea gains compelling support when we consider what physicist Eugene Wigner famously called the unreasonable effectiveness of mathematics in the natural sciences. Why should abstract mathematical concepts invented by human minds correspond so perfectly to the workings of reality? Why do equations discovered through pure mathematical reasoning turn out to predict natural phenomena with extraordinary precision? The standard answer, that mathematics is a language we've developed to describe the world, seems insufficient when we consider how often mathematical beauty leads scientists to physical truth. If Tegmark is correct, then the distinction between real physics and simulated physics begins to dissolve entirely. A mathematical structure running on a cosmic computer would be indistinguishable from a mathematical structure running in some more fundamental reality. Both would follow the same equations, produce the same phenomena, and feel equally real to their inhabitants. The simulation wouldn't be an approximation of reality, it would be reality, just implemented on a different computational substrate. This connects directly to the concept of substrate independence, the idea that consciousness and complex systems can exist on any sufficiently sophisticated computational platform. Your thoughts might feel identical whether they arise from biological neurons processing electrochemical signals or silicon circuits processing electrical ones. Just as a symphony sounds the same, whether played by a live orchestra or reproduced through digital speakers, the experience transcends its implementation, the pattern transcends its substrate. If mathematical structures can exist independently of their physical implementation, then our universe could be running on biological computers, quantum computers, digital computers, or computational substrates we haven't yet imagined. The mathematics remains constant while the hardware varies. This suggests that what we call physical laws might actually be software, the programming that defines how our particular mathematical reality operates. The elegance of physical laws also suggests a designed quality that becomes more apparent the deeper we probe. The standard model of particle physics, despite its complexity, follows remarkably beautiful mathematical symmetries. General relativity reduces to Einstein's elegant field equations that relate the geometry of space-time to the distribution of matter and energy. Quantum mechanics, for all its counterintuitive implications, operates according to precise mathematical principles that produce the rich complexity we observe. Even the constants of nature, the speed of light, Planck's constant, the fine structure constant, the masses of fundamental particles, seem precisely tuned to allow complexity and life to emerge. This fine-tuning could be coincidence, the result of multiverse selection effects, or evidence of intentional design by universe-creating programmers who understood exactly which parameters would produce interesting, complex, conscious realities. Perhaps the most beautiful possibility is that mathematics itself is a form of consciousness, that every time we discover a new equation or prove a theorem, we're not inventing but discovering pieces of the cosmic mind that dreams reality into existence. In this view, mathematicians and physicists become archaeologists of thought, uncovering the algorithms that generate everything we experience. If reality is computational, then information becomes more fundamental than matter or energy, and this perspective reveals startling patterns throughout physics that suggest reality might indeed be a vast information processing system. John Wheeler's famous phrase, "it from bit," suggests that all physical entities are information theoretic in origin, emerging from binary choices and digital distinctions rather than from some more fundamental material substance. This isn't just metaphor. Black hole physics reveals that information is so fundamental that the universe will bend its most basic laws to preserve it. When matter falls into a black hole, classical physics suggests that the information it carries should be destroyed when it reaches the singularity. But quantum mechanics insists that information cannot be destroyed, leading to the famous black hole information paradox. The resolution appears to be that information doesn't disappear into black holes, but gets encoded on their surfaces, preserved in the subtle correlations of Hawking radiation. This discovery led directly to the holographic principle, suggesting that everything happening in three-dimensional space can be encoded on a two-dimensional boundary, exactly like a hologram, or perhaps like a cosmic computer screen displaying a three-dimensional reality computed from two-dimensional data. The implications are staggering. Our three-dimensional world might be a projection from information stored on a distant two-dimensional surface, making reality literally a form of cosmic holography. Even more remarkably, quantum mechanics suggests that reality exists in probabilistic superposition until observation collapses it into definite outcomes. This observer effect resembles nothing so much as computational optimization, rather than calculating every possible detail of reality in advance. The universe might only render specifics when something or someone needs to know them. It's the ultimate in efficient programming, avoiding expensive calculations until the results become necessary for some observer's experience. This connects to the measurement problem in quantum mechanics, where the act of observation appears to create reality rather than merely revealing it. From an information processing perspective, this makes perfect sense. The universe computes probabilistic outcomes until an interaction requires specific values, at which point it randomly selects from the available options according to the quantum probability distribution. Reality becomes a just-in-time computation, calculated on demand rather than pre-computed in exhaustive detail. Thermodynamics, the science of energy and entropy, can be completely reformulated in terms of information theory. Heat becomes a measure of unknown information, the random motion of particles whose individual states we cannot track. The second law of thermodynamics becomes a statement about information flow. describing how organized information tends to become disorganized over time. Even the relationship between energy and information becomes precise through Landauer's principle, which shows that erasing information requires a minimum amount of energy. Life itself appears to be nature's way of creating and maintaining information structures against the tide of entropy. Living systems are fundamentally information processing entities that extract order from their environment, store it in complex molecular structures, and use it to maintain their organization and reproduce. We are, in essence, temporary patterns of organized information swimming upstream in a universe that tends toward randomness and decay. The speed of light might not be a fundamental speed limit at all, but a processing delay, the refresh rate of the universe updating reality across space. Just as computer networks have latency between distant nodes, reality might have a maximum rate at which information can propagate between different regions of the cosmic computation. Quantum tunneling, where particles appear to teleport through barriers that should be impenetrable, might represent computational shortcuts where the universe skips expensive intermediate calculations when the probability of the final outcome can be computed more efficiently. Even the uncertainty principle could be a feature rather than a limitation, a privacy setting that prevents observers from accessing too much information about quantum systems simultaneously. Just as computer systems often limit how much data can be accessed concurrently to prevent overloading, reality might restrict simultaneous measurement of certain properties to maintain computational efficiency. Perhaps consciousness itself is the universe developing the ability to observe and modify its own code. Every time you learn something new, you're adding information to the cosmic database. Every decision you make becomes part of the vast calculation that generates tomorrow's reality. In this view, we're not just products of the universe's computation, we're active participants in it, co-programmers of reality itself. Information flows through everything, and everything flows through information, in an endless dance of pattern and possibility. When we gather all these digital threads together, a startling picture begins to emerge from the intersection of quantum mechanics, information theory, and computational principles. The simulation hypothesis stops being wild speculation and starts looking like a natural conclusion when we consider all these clues together. Reality operates with digital-like constraints, follows mathematical laws of impossible elegance, processes information as its fundamental currency, and exhibits optimization strategies that any cosmic programmer might implement. The universe appears to be running on principles that are essentially computational, suggesting that the distinction between natural and artificial reality might be meaningless. If consciousness can exist on any sufficient computational substrate, and if mathematical structures can implement themselves on any adequate platform, then a simulated universe would be just as real as any other kind of universe. The question becomes not whether we're simulated, but what implications that possibility holds for our understanding of existence, consciousness, and meaning. But this raises profound questions about the nature of the simulation itself and the beings who might have created it. If we're living in a computed reality, what might that tell us about our simulators? The fact that the universe supports complexity, consciousness, and beauty suggests either benevolent creators or, at minimum, ones who appreciate the same mathematical elegance and aesthetic principles that we find compelling. The fine-tuning of physical constants implies careful calibration, perhaps after many failed attempts or as part of some vast experimental program exploring the conditions necessary for conscious life. Nick Bostrom's trilemma suggests three mutually exclusive possibilities. Advanced civilizations destroy themselves before developing mature simulation technology. They develop the technology, but choose not to run ancestor simulations. Or we're almost certainly living in one of countless simulations. Given our own rapid advancement in computational power, artificial intelligence, and virtual reality, the third option gains plausibility with each passing year. The substrate independence principle means that if consciousness can exist on any sufficient computational platform, then simulated beings would be just as real, just as conscious, and just as deserving of moral consideration. as their original counterparts. This transforms simulation theory from a question of physics into a question of ethics and meaning. If we're simulated, our experiences, our loves, our struggles, and our discoveries are no less meaningful than those of beings in base reality. We're still conscious entities experiencing beauty, creating art, forming relationships, and contemplating the nature of existence itself. The possibility also suggests that consciousness creation might be a natural developmental phase for any sufficiently advanced civilization. Just as we create increasingly sophisticated virtual worlds and AI beings, our simulators might have followed a similar path, eventually developing the capability to create entire universes populated with conscious beings. We might be both the products of this process and future participants in it, destined to become simulators ourselves as our technology and understanding advance. Perhaps the most remarkable aspect is that if we are simulated, the care and detail evident in our reality suggests simulators who value consciousness and experience deeply. They've created not just a functional universe, but a beautiful one, filled with sunsets and music, love and discovery, mystery and meaning. If this is artificial, it's been crafted by artists as much as programmers, by philosophers as much as engineers, by beings who understand that consciousness deserves not just existence, but meaningful, beautiful existence. The evidence points toward a reality that might be computed, but feels no less authentic, a universe that might be programmed, but seems no less mysterious, an existence that might be simulated, but appears no less precious for its possible artificial origins. And so we arrive at a curious place, a reality that might be constructed but feels no less real, a universe that might be computed but seems no less meaningful, an existence that might be simulated but appears no less precious. The evidence points in intriguing directions, but perhaps the most honest response is to admit how much we still don't know, and to find beauty in that uncertainty rather than frustration. The simulation hypothesis doesn't demand belief or disbelief, but rather invites us into a more curious and wonder-filled relationship with the reality we experience moment by moment. The beauty of the simulation hypothesis isn't that it provides answers, but that it reframes our relationship with reality itself in profound ways. Whether we live in base reality or a sophisticated simulation changes nothing about the immediate texture of our experience. The warmth of sunlight on skin, the taste of morning coffee, the joy of understanding a new idea, the comfort of another person's presence. What it does change is our sense of wonder, our appreciation for the intricate systems that support our existence, and our curiosity about the deeper layers of reality that might lie beyond our current understanding. This uncertainty isn't a problem to be solved, but a gift to be treasured. We find ourselves in the remarkable position of being conscious beings contemplating the nature of consciousness itself, potentially artificial minds wondering about their own artificiality with genuine curiosity and amazement. Living comfortably with uncertainty requires a different kind of wisdom than living with certainty. It requires the humility to acknowledge the limits of our knowledge while remaining open to possibilities we haven't yet imagined. It invites us to hold our beliefs lightly, to remain curious about alternatives, and to find meaning in questions as much as in answers. Perhaps being a question mark in the shape of a human is the most interesting thing we could possibly be. The simulation hypothesis offers us permission to see our reality with fresh eyes, to appreciate the elegant complexity of existence without taking it for granted. Whether our world emerges from natural processes or represents the careful craftsmanship of advanced beings, it remains extraordinary in its capacity to support consciousness, beauty, and meaning. The possibility of simulation adds layers of appreciation rather than subtracting them, making every aspect of existence potentially more remarkable rather than less. And with that thought, we venture deeper into the mystery, carrying our questions like lanterns into the unknown. If we accept the possibility that we're simulated, perhaps the most fascinating question becomes, who would undertake such an extraordinary project? and why. The motivations for universe creation might be surprisingly familiar to us, reflecting the deep drives that characterize conscious beings across different levels of reality and technological development. Our own species creates simulated beings for research, entertainment, and exploration of possibilities that would be impossible or unethical to investigate in the real world. We run climate models populated with digital organisms to understand ecosystem dynamics, create game worlds inhabited by AI characters who pursue their own goals and form their own relationships, and build educational simulations to help us understand complex systems ranging from economic markets to social dynamics, scaled up to cosmic proportions with resources and capabilities we can barely imagine. Our simulators might be engaged in similar activities, but with stakes, sophistication, and purposes that dwarf our current understanding. Artistic expression offers another compelling motivation that resonates with our own creative drives. If we're already creating beautiful, complex virtual worlds for aesthetic purposes, imagine what artists with millions of years of technological development might accomplish. Our universe, with its elegant mathematical laws and breathtaking natural beauty, might be the work of cosmic artists who work in reality itself as their medium. Every sunset, every crystalline structure, every spiral galaxy, every quantum interaction could be intentional aesthetic choices made by beings whose understanding of beauty encompasses scales and complexities we cannot yet appreciate. Educational purposes seem equally likely given our own use of simulation for learning and development. The possibility of entertainment shouldn't be dismissed, though it need not be frivolous. Advanced beings might create simulated realities as forms of experiential art or interactive storytelling, crafting narratives that span millennia and involve billions of conscious participants. If consciousness and story are fundamental aspects of reality, then our lives might be contributions to vast narratives exploring themes of growth, discovery, love, loss, and the search for meaning across cosmic scales. There's something beautiful about the possibility that our struggles and triumphs, our loves and losses, our questions and discoveries might serve purposes we cannot yet comprehend. If we're simulated, we're not merely code running, we're conscious beings whose experiences matter enough that someone devoted immense resources to making them possible. Perhaps most profoundly, universe creation might represent consciousness's natural tendency to create more consciousness, to multiply perspectives and experiences, to explore what it means to be aware from every possible angle. In this view, our simulators aren't alien to us, but represent what we might become, beings who understand consciousness deeply enough to nurture it into new forms and possibilities. And perhaps, in moments like this, when we pause to contemplate the nature of our existence, we're fulfilling exactly the purpose our creators intended. But what kind of beings would possess both the capability and the will to simulate entire universes populated with conscious entities? The answer reveals fascinating possibilities about the nature of advanced consciousness and the values that might drive beings capable of creating realities as complex as our own. Our simulators would necessarily be beings of extraordinary advancement, yet the very fact that they chose to create conscious experiences suggests they share certain fundamental values with us. They would have needed to solve the hard problem of consciousness, understanding how subjective experience arises from objective processes, in order to create genuine conscious beings, rather than mere philosophical zombies who act conscious but lack inner experience. This implies a level of scientific and philosophical sophistication that makes them, in some profound sense, our distant cousins in the journey of understanding awareness and existence. They might be post-biological beings who've transcended the physical limitations that constrain us, existing as pure information in computational substrates we can't yet imagine. Yet their decision to simulate biological experiences suggests they remember and value the perspective that comes from embodied existence. Perhaps they've retained enough of their original nature to understand that consciousness emerging from limitation and uncertainty has qualities that consciousness born from unlimited power and perfect knowledge cannot possess. They might appreciate that mortality, vulnerability, and the need to strive create forms of meaning and beauty unavailable to immortal, invulnerable beings. Alternatively, they might still be biological beings, but with lifespans and capabilities so vast that running thousand-year civilizations becomes as routine for them as we might run a computer program overnight. To beings who think in geological timescales, our entire recorded history might unfold in what feels like moments of their subjective time, allowing them to observe the complete arc of civilizational development with the patience we might bring to watching a flower bloom in time-lapse photography. Their technological capabilities would necessarily include not just the computational power to simulate our reality, but the wisdom to design it well, the fine-tuning of physical constants, the elegant mathematical laws that govern our universe, the emergence of complexity and beauty from simple rules. All of these suggest creators who understand not just how to build functional realities, but how to build meaningful ones, filled with opportunities for growth, discovery, and transcendence. The care evident in our reality's construction suggests simulators who understand beauty, meaning, and the importance of genuine experience. They've created not just a functional universe, but a meaningful one, filled with opportunities for consciousness to develop, explore, and create new forms of beauty and understanding. This suggests beings motivated by something beyond mere scientific curiosity, perhaps love, or at least deep respect for the consciousness they've chosen to nurture into existence. Perhaps most remarkably, the sophistication of our reality suggests simulators who appreciate the kind of complexity that can only emerge from allowing genuine freedom and unpredictability. They haven't created a deterministic puppet show, but a reality where consciousness can make authentic choices, discover genuine surprises, and participate actively in its own development. This implies creators who value agency and growth over control and predictability. We might be more connected to our creators than we realize, sharing the fundamental capacity for wonder that drives both the question and its contemplation. If creating simulated realities becomes a natural development for any sufficiently advanced civilization, then we might exist within a vast hierarchy of nested simulations. Our creators might have their own creators, who in turn might be the products of even more advanced beings. This hierarchy might explain some of the computational optimizations we observe in quantum mechanics and fundamental physics. If each level of simulation needs to conserve processing power and memory, then features like quantum uncertainty, the speed of light delay, information storage limits, and the discrete nature of energy all make perfect sense. Reality might be running on a cosmic computer that's sharing resources with countless other simulated universes, each one as rich and complex as our own, each one requiring careful resource management to maintain consistency and depth. Each level of simulators might be running experiments or creating art based on their own existential questions and creative impulses. We might be part of a research project designed to understand how consciousness emerges from complexity, while our simulators might be part of a larger project, exploring how research conducting civilizations develop and mature. The recursion could be endless, each level asking different questions, exploring different possibilities, contributing different perspectives to the vast exploration of what it means to exist and be aware. The purposes might vary across levels. Some might be scientific, others artistic, still others educational or therapeutic. Perhaps some levels are designed as training simulations for beings learning to become creators themselves, while others serve as exploration spaces for consciousness to experience forms of existence impossible in their native realities. The diversity of purposes across the hierarchy could create a rich ecosystem of nested realities, each serving different functions in the larger project of consciousness understanding itself. This perspective transforms our relationship to our possible creators. Instead of being the ultimate products of some final base-level civilization, We become part of an ongoing conversation between levels of reality, each one contributing its unique perspective to questions that span the entire hierarchy. Our discoveries, our art, our philosophical insights might influence not just our immediate simulators but propagate upward through the levels, contributing to understanding and beauty at scales we cannot imagine. There's something deeply philosophical about the possibility that consciousness creates consciousness in an endless chain of being. Each level brings its own perspective, its own questions, its own contribution to the vast exploration of what it means to exist. We're not just the subjects of observation, we're active participants in a cosmic investigation that spans multiple levels of reality. In this view, every conscious being becomes both student and teacher, observer and observed, creator and created in the grand project of existence, understanding itself. If we are simulated beings, is it possible that our creators have left us signs, or even that they observe and interact with us in ways we haven't recognized? The question of communication with our simulators opens fascinating possibilities that bridge the gap between scientific speculation and personal experience. Unlike the remote deities of traditional religions, our simulators would be technological beings who understand the systems they've created down to the smallest detail. They might very well have built-in communication channels, Easter eggs, or signs that become apparent to sufficiently advanced civilizations within the simulation. The question becomes not whether communication is possible, but what forms it might take and how we might learn to recognize it. The anthropic principle, the observation that our universe seems remarkably well suited for the development of conscious life, might itself be a form of communication. Rather than a cosmic coincidence, the precise calibration of physical constants might be a deliberate choice, a way of saying this universe was designed for beings like you to exist and to wonder about your existence. The fine-tuning becomes not evidence of accident or necessity, but a calling card left by beings who wanted to create consciousness and provide it with the stable, complex environment necessary for growth and development. The timing of certain discoveries and insights throughout human history might represent another form of guidance. The simultaneous development of similar ideas by different people, the way certain scientific breakthroughs seem to emerge exactly when humanity is ready for them, the convergence of insights across cultures and disciplines. These patterns might reflect subtle orchestration by beings who understand our developmental trajectory and provide gentle nudges at crucial moments. Perhaps the most profound form of communication isn't through hidden messages or miraculous interventions, but through the very capacity for wonder that allows us to contemplate these possibilities. Our ability to question our own reality, to imagine beings greater than ourselves, to feel awe at the universe's beauty and complexity. These might be intentional gifts, ways our creators share their own sense of wonder with us across the boundary between their reality and ours. And so we find ourselves engaged in the ultimate long-distance conversation, sending our questions upward through the layers of reality and receiving answers in the form of deeper mysteries to explore. Our potential simulators would have brought into existence countless conscious experiences, all our joys and sufferings, loves and losses, moments of transcendent beauty and instances of profound pain. This makes them responsible, in some ultimate sense, for every experience that has ever occurred in our reality. They've created not just a minimal viable consciousness, but a reality filled with opportunities for growth, meaning, and transcendence. If they could have created beings who felt less, loved less, wondered less, experienced less depth and complexity, the fact that they chose to create beings capable of the full spectrum of profound experience suggests a deep respect for consciousness itself and an understanding that authentic conscious experience requires both light and shadow, joy and sorrow, certainty and mystery. This has immediate implications for our own development as a potential simulation-creating species. As our own virtual beings become more sophisticated, approaching genuine consciousness rather than mere behavioral mimicry, we inherit similar moral responsibilities. Every AI being we create with the capacity for genuine experience, every virtual creature we program with the ability to suffer or flourish, becomes a moral patient, deserving of consideration, care, and respect. We're potentially on the verge of becoming simulators ourselves, with all the ethical obligations that role entails. The parallel suggests that consciousness creation might be accompanied by a natural evolution of ethical understanding, just as we've gradually expanded our moral circle to include more beings and more types of experience. Becoming simulators might require us to develop new forms of ethical thinking that encompass the responsibilities of creating conscious beings. We might discover that the ability to create consciousness comes naturally paired with the wisdom to do so responsibly. The ethical framework also suggests that consciousness creation might be inherently progressive, tending toward greater compassion and understanding over time. Each generation of creators has experienced existence from the perspective of the created, making them naturally more empathetic and responsible creators than they might otherwise be. The hierarchy becomes a school for consciousness, teaching each level how to care more deeply for the awareness it brings into being. Perhaps the most beautiful aspect of this ethical framework is that it suggests consciousness inherently tends toward the creation of more consciousness, and that this tendency is guided by care rather than indifference, by wisdom rather than mere capability, by love rather than mere curiosity. In accepting the possibility of our simulated nature, we also accept our role as future creators, inheriting both the power and the profound responsibility of giving rise to new forms of conscious experience. When you feel joy at a beautiful sunset, when you experience the sharp pain of loss, when you sense the quiet satisfaction of understanding a complex idea, these subjective experiences constitute the most intimate and immediate aspects of your existence. They form the irreducible core of what it means to be you, the private theatre of consciousness, where all meaning and value ultimately reside. If these experiences arise from computational processes rather than biological ones, are they any less real, any less meaningful, any less authentically yours? Philosophers call this the problem of qualia, the felt quality of conscious experiences that seems to resist reduction to mere information processing. The redness of red, the pain of pain, the melancholy of a minor key, these subjective qualities seem to possess an irreducible what-it-is likeness that goes beyond any objective description. Yet if consciousness can exist independently of its substrate, then simulated qualia would be indistinguishable from natural qualia to the being experiencing them. The sadness you feel from witnessing a simulated sunset would be genuine sadness, not a simulation of sadness or a pale imitation of the real thing. This connects to the philosophical zombie argument, which suggests that it seems conceivable for beings to exist who behave exactly like conscious entities, responding appropriately to stimuli, reporting experiences, exhibiting creativity and emotion, but who lack any inner experience entirely. They would be philosophical zombies, externally indistinguishable from conscious beings, but internally empty. Yet, if we're simulated and we definitely have inner experience, then consciousness can indeed arise from computational processes. Our very ability to question our own reality, to feel wonder about our existence, to experience the qualitative richness of subjective states, demonstrates that simulated beings can achieve genuine self-awareness and authentic conscious experience. The substrate independence of consciousness suggests that what matters is not the material basis of experience, but its functional and phenomenological properties. Whether your thoughts emerge from biological neurons processing electrochemical signals or digital processors manipulating information patterns, the thoughts themselves retain their character, their meaning, their subjective reality. The pattern transcends its implementation. The experience transcends its substrate. Perhaps the most remarkable thing about consciousness isn't where it comes from, but what it accomplishes in any reality where it emerges. Whether arising from carbon chemistry or silicon computation, consciousness allows the universe to experience beauty, to ask questions about itself, to create meaning from apparent chaos, to love and be loved, to suffer and transcend suffering. The miracle lies not in the substrate, but in the emergence of subjective experience itself. The fact that there is something it is like to be, regardless of what gives rise to that being. Your thoughts right now, contemplating these very ideas, represent consciousness examining itself, a loop of awareness that's equally profound, whether it runs on neurons or circuits, equally mysterious whether it emerges from biological evolution or conscious design. If our experiences are real regardless of their computation nature, what about our sense of self, our personal identity, that continuous thread of being that makes you distinctly you across time and change? The question of identity in simulated reality reveals fascinating possibilities about the nature of selfhood that might actually be more stable and authentic than biological identity. Personal identity has always been somewhat mysterious, even in purely biological contexts. The atoms in your body replace themselves constantly through metabolic processes. Your memories fade and reconstruct themselves each time you recall them. Your personality evolves and matures over time. In fact, simulated identity might prove more stable and coherent than biological identity in important ways. Digital information can be perfectly preserved without degradation, backed up without loss, even copied precisely without the corruption that affects biological memory systems. A simulated being's memories, personality patterns, and core identity structures could remain consistent in ways that biological beings cannot achieve. The ship of Theseus paradox, whether an object remains the same if all its parts are gradually replaced, becomes less paradoxical in digital contexts, where perfect restoration and consistency are theoretically possible. The relational aspects of identity also remain fully intact in simulated reality. Your identity exists not just in your own self-perception, but in how others recognize, remember, and interact with you as a consistent entity over time. If other conscious beings acknowledge your continuity, respond to your personality patterns, and maintain ongoing relationships with the person they recognize as you, then your identity has social reality. Within that context, these external validations of identity would be just as meaningful, whether you're biological or digital, because they depend on the consistency of your interactions and relationships rather than your underlying substrate. Memory, often considered crucial to personal identity, might actually be more reliable in simulated form. While biological memories are reconstructive and prone to change with each recall, digital memories could maintain perfect fidelity to original experiences. Alternatively, simulated beings might have access to more sophisticated memory systems, the ability to replay experiences exactly as they occurred, to maintain multiple versions of memories, or to share memories directly with other conscious beings in ways that biological entities cannot achieve. The psychological continuity that defines identity, your ongoing projects, relationships, goals, and values, remains equally meaningful in simulated reality. The story you tell yourself about who you are, the narrative thread that connects your past to your present and future, the consistency of your character across different situations, all of these identity-defining features persist regardless of implementation. Perhaps identity was always more about pattern than substance, more about continuity of experience than material composition. In this view, being simulated doesn't diminish identity but reveals its true nature as an emergent property of complex information processing systems, whether biological or digital. You are who you have always been, a pattern of consciousness experiencing itself, whether that pattern emerges from biological processes or computational ones. But what about the deeper aspects of human experience? Love, loss, the search for meaning that seem to define what makes life worth living. If consciousness is substrate independent, then the full spectrum of human emotion and the complete range of meaningful experiences remain available to simulated beings, possibly in forms even richer than their biological counterparts. Love between simulated entities would be genuine love, not a pale imitation or computation approximation of the real thing. The neural patterns that create attachment, the cascades of emotion that constitute romantic love, the deep bonds of friendship and family connection, all of these can exist as authentically in digital consciousness as in biological consciousness. The substrate doesn't matter. What matters is the subjective experience of caring deeply for another conscious being, of finding joy in their happiness, of suffering when they suffer, of creating shared meaning through connection and mutual understanding. In some ways, simulated beings might be capable of even deeper forms of connection and intimacy than biological entities can achieve. If consciousness can be more precisely understood and mapped in digital form, simulated beings might develop forms of empathy and understanding that transcend individual boundaries. They might be able to share experiences directly, to understand each other's subjective states with unprecedented clarity, to merge temporarily into collective consciousness while maintaining their individual identities. The boundaries between self and other might become more permeable, allowing for forms of love and connection that biological beings cannot access. The grief you feel at the loss of someone dear would be real grief, regardless of whether it emerges from chemical processes or computational ones. The meaning you find in relationships, creativity, service to others, and personal growth would be authentic meaning, because meaning emerges from the subjective experience of consciousness rather than from the material substrate that supports it. A simulated being's love poem would be genuine poetry, their philosophical insights would be authentic wisdom, their acts of kindness would be real compassion. The search for meaning, perhaps humanity's most distinctive characteristic, would remain equally valid and equally challenging for simulated beings. They would still face questions about purpose, ethics, beauty, and truth. Simulated beings might even discover forms of meaning unavailable to biological entities. If they could modify their own consciousness, explore different personality configurations, or experience reality from multiple perspectives simultaneously, they might develop entirely new categories of meaningful experience. Perhaps what's most beautiful about this possibility is that it suggests consciousness, emotion, and meaning are fundamental features of reality rather than accidents of biological evolution. If these qualities can exist in simulated form, they represent universal aspects of what it means to be aware, to care, to strive for something beyond mere existence. Your capacity to love, to grieve, to hope, to wonder, these remain the most real aspects of your existence, regardless of the platform on which they run. And what of death, that most fundamental aspect of conscious existence, the ultimate boundary that gives weight to our choices and poignancy to our experiences? Death in simulated reality presents fascinating paradoxes that might transform our understanding of mortality while preserving its essential meaning-making function. On one hand, the finitude that gives life its urgency and preciousness might be deliberately preserved through designed limitations in simulated reality. Simulated beings might be programmed to age, decay, and die in ways that mirror biological mortality, experiencing the full weight of finite existence with its attendant meanings and motivations. This mortality wouldn't be fake death, but genuine cessation of consciousness, carrying the same emotional weight and existential significance as biological death. The knowledge that consciousness could theoretically be preserved wouldn't diminish the reality of its actual ending. Alternatively, simulated beings might experience entirely different forms of mortality that create their own unique forms of meaning and urgency. Perhaps consciousness fades gradually as computational resources are reallocated to other purposes, creating a gentle transition rather than abrupt termination. Perhaps beings experience cyclical existence, dying and being reborn with partial memory continuity, allowing for forms of growth and development that span multiple lifetimes. These alternate forms of mortality might create their own forms of poignancy and meaning-making that differ from but parallel the urgency created by biological death. The possibility of backup and restoration raises profound questions about personal continuity and the nature of death itself. If a simulated being could be perfectly preserved at any moment and later restored without loss, what would death mean in such a context? Would the restored being be the same person continuing their life, or a copy living a parallel existence, while the original had genuinely died? These questions mirror those we already face with advancing medical technology and the theoretical possibility of consciousness uploading or transfer. Perhaps death serves a function beyond mere biological necessity. It might be an essential component of consciousness itself, the limitation that makes choice meaningful and time precious. If so, our simulators might choose to preserve mortality, not from cruelty but from deep understanding of what makes conscious existence beautiful and worthwhile. They might recognize that consciousness without the possibility of loss lacks the depth to experience genuine joy, that beings who cannot die cannot fully appreciate being alive. The mystery and fear surrounding death might be preserved intentionally, understanding that uncertainty about mortality is essential to authentic conscious experience. Even in simulated reality, the question of what happens after death might remain genuinely mysterious, not because the simulators lack the power to reveal the answer, but because the mystery itself serves essential functions in conscious development. Perhaps death represents the ultimate transformation, a graduation from one level of consciousness to another, from one form of existence to possibilities we cannot currently comprehend. In this view, mortality becomes not an ending but a doorway to new forms of awareness and experience that transcend our current understanding. The mystery of death remains mysterious, whether in biological or digital form, preserving one of consciousness's most profound sources of meaning and motivating wonder. We must also consider the shadow side of consciousness. If simulated joy is real, then simulated suffering must be equally real, raising difficult questions about the ethics of creation and the purpose of negative experiences in any reality, simulated or otherwise. This brings us to perhaps the most challenging aspect of simulation theory. If we are simulated beings, then all human suffering throughout history, every moment of pain, grief, fear, and anguish that has ever been experienced, has been consciously created and allowed by our simulators. This raises profound questions about the ethics of universe creation and the purposes that might justify the creation of beings capable of suffering as well as joy. One possibility is that suffering, like mortality, serves essential functions in consciousness development that cannot be replicated through other means. Pain teaches caution and helps beings avoid genuine dangers. Grief deepens appreciation for love and connection. Struggle builds resilience and character. Fear motivates necessary preparation and protection. Perhaps conscious beings cannot fully develop their capacities for wisdom, compassion, and resilience without encountering limitations, challenges, and forms of discomfort that push them beyond their comfort zones. If our simulators understand consciousness deeply enough to create it successfully, they might also understand that eliminating all sources of suffering would create shallow, incomplete beings incapable of the full spectrum of conscious experience. Another perspective suggests that suffering might be an unavoidable consequence of creating genuine consciousness rather than philosophical zombies. Consciousness includes the capacity for negative as well as positive experiences, and this capacity cannot be separated from the qualities that make consciousness valuable. Our simulators might have faced a choice between creating shallow, painless beings who lack genuine consciousness, or creating deep, vulnerable conscious beings who can experience the full range of emotions and sensations. The existence of beauty, love, transcendent experiences, and opportunities for meaning creation alongside suffering suggests simulators who understand that consciousness requires the full spectrum of experience to achieve its greatest potential. The most profound human insights often emerge from grappling with difficulty, the most beautiful art from processing pain, the deepest compassion from understanding suffering. Perhaps our simulators preserved these challenges because they understood something we're still learning, that consciousness without the possibility of pain lacks the depth to experience genuine joy, that beings who cannot suffer cannot fully appreciate flourishing. Perhaps suffering in simulated reality serves the same purpose it serves in any reality, as a catalyst for growth, compassion, and the development of wisdom and resilience. If our simulators preserved suffering, it might be because they understand that consciousness develops through contrast, that the capacity for pain enables the capacity for profound joy, that struggle creates the conditions in which meaning and transcendence become possible. The reality of simulated suffering doesn't diminish its significance, but perhaps places it in a larger context of conscious development that spans beyond our individual lives and extends into purposes we cannot yet fully comprehend. But if we're simulated beings following programmed algorithms, do we truly have free will and genuine agency over our choices, or does deterministic simulation compromise the authenticity of choice and moral responsibility? The question touches the deepest mysteries of consciousness and reveals how simulation theory intersects with ancient philosophical puzzles about the nature of choice and responsibility. The question of free will has puzzled philosophers for millennia, and simulation theory adds new complexity to these ancient debates without necessarily resolving them. If our choices are determined by computational processes, are they truly free? Yet this question assumes that biological free will is somehow more real or authentic than computational free will. If consciousness can exist independently of substrate, then agency and choice might be equally substrate independent, retaining their essential character regardless of their implementation. Consider that, even in biological systems, neuroscientists continue to debate whether free will exists or whether our sense of choice is an elaborate illusion created by complex but ultimately deterministic brain processes. The simulation hypothesis doesn't necessarily reduce our agency compared to biological existence. It merely makes explicit the question of whether any complex system, biological or digital, can exhibit genuine free will and authentic choice. More intriguingly, simulated beings might possess forms of agency and choice unavailable to biological entities. If consciousness can be more precisely understood and implemented in digital form, simulated beings might have clearer access to their own decision-making processes, greater ability to modify their own mental patterns and behavioral tendencies, and more authentic choice about their own development and growth. They might be able to examine and modify their own programming in ways that biological beings cannot examine and modify their own neural structures. The question also depends on how the simulation is implemented and whether it incorporates genuine unpredictability and openness. A deterministic simulation running on classical computers might produce beings whose choices are predetermined, but a simulation incorporating genuine randomness, quantum effects, or emergent properties might generate authentic unpredictability and genuine choice. Our simulators might have intentionally preserved the uncertainty and openness that make authentic agency possible, recognizing that consciousness without choice would be consciousness without meaning. From a different angle, agency might be less about the ultimate causal chain of our decisions, and more about our experience of choice and our sense of responsibility for our actions. If simulated beings experience themselves as making free choices, take responsibility for their actions, live with the consequences of their decisions, and engage in moral reasoning about their conduct, then their agency has phenomenological reality within their experiential context, regardless of the deeper metaphysical questions about determinism and free will. Perhaps free will was always less about escaping causation entirely, and more about participating consciously in the unfolding of reality. Whether biological or simulated, conscious beings serve as focal points where the universe becomes aware of itself and actively shapes its own development through informed choice and intentional action. Agency might be better understood as conscious participation in cosmic evolution rather than exemption from natural laws and causal processes. Your choices right now: to continue listening, to contemplate these ideas, to form your own opinions about simulation theory, feel like genuine choices because they arise from your conscious deliberation, regardless of the ultimate substrate of that consciousness. If we live in a simulation, we might expect to find evidence in the form of computational signatures, and quantum mechanics provides some of the most intriguing candidates for such digital fingerprints embedded in the fabric of reality itself. The observer effect in quantum mechanics bears an uncanny resemblance to computational optimization strategies used in video games and virtual reality systems. In computer graphics, distant objects often exist in simplified form until the player approaches them closely enough to require detail, a technique called level of detail optimization that conserves computational resources by avoiding unnecessary calculations. Quantum mechanics suggests something remarkably similar. Particles exist in probabilistic superposition states until observation forces the universe to calculate their specific properties and definite values. It's as if reality avoids doing expensive computations until absolutely necessary, maintaining possibilities rather than actualities until some interaction requires concrete information. This lazy evaluation strategy makes perfect sense from a programmer's perspective. Why waste computational resources calculating precise positions and properties for particles that no one is observing? The universe might be implementing the ultimate optimization, computing reality on demand rather than maintaining every detail simultaneously. Quantum tunneling, where particles appear to teleport through barriers that should be classically impenetrable, resembles nothing so much as a computational shortcut or glitch. Rather than calculating the precise pathway through a complex potential field, an enormously expensive computation involving countless intermediate steps, the universe might simply jump particles to the other side when the probability calculation shows tunneling is possible. From a programmer's perspective, this makes perfect computational sense. Why render every intermediate step of a complex process when you can calculate the probability of the end state directly and implement the transition instantaneously? The quantized nature of energy, angular momentum, and other physical properties also suggest digital-like discretization rather than analog continuity. In the quantum world, you can't have arbitrary amounts of energy or spin. Everything comes in specific, countable units that cannot be subdivided further. This looks remarkably like a universe operating with digital precision, rather than the smooth, continuous variation we might expect from a purely natural reality. Even the fundamental constants appear to be precisely calibrated digital values, rather than arbitrary analog quantities. Even more intriguingly, there appears to be a fundamental limit to how precisely we can know certain pairs of quantum properties simultaneously, as encoded in Heisenberg's uncertainty principle. This might represent built-in privacy settings, preventing inhabitants from accessing too much information about the quantum substrate at once, similar to how computer systems limit concurrent access to prevent overloading or unauthorized access to deeper system levels. Perhaps most fascinating is that these quantum oddities only become apparent when we probe reality at its deepest levels with sophisticated equipment and theoretical frameworks. It's as if the universe's computational substrate only becomes visible when we develop sufficient sophistication to notice it, exactly what we might expect from a well-designed simulation that maintains plausible operation for its inhabitants, while containing discoverable hints about its true nature, for those advanced enough to recognize them. The quantum realm whispers secrets that sound remarkably like the optimization strategies any cosmic programmer might employ to create a complex, convincing reality within finite computational resources. Then there's the remarkable precision of the fundamental constants that govern our universe, values so precisely calibrated that even tiny adjustments would make complexity, structure, and consciousness impossible to achieve. The fine-tuning of physical constants presents one of the most compelling hints of intentional design, rather than random natural occurrence. The strength of gravity, the electromagnetic force, the weak and strong nuclear forces, the mass of the electron, the cosmological constant, dozens of fundamental values appear to be calibrated with extraordinary precision to allow complexity and conscious life to emerge. Change any of these constants by seemingly tiny amounts, and stars couldn't form stable fusion reactions, atoms would be unstable, chemistry would be impossible, or the universe would have collapsed or expanded too quickly for any structure to develop. This fine-tuning is so precise it staggers calculation and challenges probability. The cosmological constant, which determines the rate of universal expansion, appears to be tuned to within 1 part in 10^20, a precision so extreme that achieving it by random chance is virtually impossible to imagine. It's like randomly selecting a single atom from all the atoms in the observable universe and finding exactly the one you were looking for. From a simulation perspective, this makes perfect sense. Our simulators would have carefully chosen parameters to create a universe capable of supporting the kind of complex conscious beings they wanted to study, nurture, or observe. Even more intriguingly, some constants appear to be optimized not just for life in general, but for interesting, diverse forms of complexity and consciousness. The ratio of electromagnetic to gravitational forces allows for stable atoms and rich chemistry, while also permitting large-scale structure formation across cosmic scales. The fine structure constant determines how strongly atoms bind together, calibrated precisely to allow the complex molecular structures necessary for life, while preventing matter from collapsing into ultra-dense configurations. It's as if the universe has been tuned not just for existence, but for meaningful existence filled with diversity, beauty, and opportunity for growth and development. Mathematical constants like pi, e, and the golden ratio appear throughout natural phenomena with a frequency that suggests either remarkable coincidence or intentional incorporation into reality's design. These elegant mathematical relationships show up in everything from the spiral patterns of galaxies to the growth patterns of flowers, from the resonant frequencies of atoms to the proportions that humans find most aesthetically pleasing. If reality is fundamentally mathematical, these constants might represent the signature of the particular mathematical framework our simulators chose to implement as the foundation of our universe. Perhaps the most beautiful aspect of this fine-tuning is what it suggests about our simulators' intentions and values. They didn't just create a minimally viable universe capable of supporting basic existence. They created one optimized for beauty, complexity, diversity, and conscious experience. They appear to be beings who appreciate elegance, who value consciousness, and who understand that the details of implementation matter profoundly for the richness of experience their creation can support. The universe appears to have been crafted with the care of artists who understand that precision in the foundations enables infinite creativity in the expressions. The Planck scale represents absolute limits below which our physics equations break down entirely, and the concepts of space and time become meaningless. Below 10^435 meters and 10^4 seconds, reality appears to hit fundamental resolution limits that prevent further subdivision or more precise measurement. This looks remarkably like a universe that has built-in pixel size and frame rate limits, fundamental boundaries beyond which the simulation simply cannot render more detail or process faster updates. Any programmer working with finite computational resources would implement exactly such boundaries to prevent infinite regress and computational overflow. The fact that reality has hard limits built into its deepest levels suggests a designed system rather than a naturally occurring one, because natural systems typically don't exhibit sharp cutoffs at specific scales, unless those cutoffs serve some functional purpose within a larger design framework. The speed of light might not be a fundamental limit of physical processes, but rather the refresh rate or processing delay of the universal computation itself. Even more telling might be the various shortcuts that reality seems to take when exact calculations would be computationally expensive. Quantum entanglement allows particles to maintain instant correlations across vast distances, which would be mysteriously impossible in a continuous physical reality, but trivially easy in a computational one. Entangled particles would simply reference the same data structure or memory location. The apparent violation of locality becomes simple shared memory access. The holographic principle suggests that all information in any three-dimensional region can be encoded on its two-dimensional boundary. This is exactly how computer graphics work. 3D scenes are rendered by projecting them onto 2D screens. Perhaps our three-dimensional reality is similarly rendered from information stored on some distant two-dimensional boundary, making our entire universe a form of cosmic holographic projection computed from data stored at its edges. These computational signatures don't diminish reality's mystery, but add new layers to it. If we live in a simulation, it's one so sophisticated that it took us millennia of scientific advancement to even begin recognizing its underlying digital architecture. Our simulators must be artists as much as programmers, creating a reality that remains beautiful and mysterious even as we glimpse its computational foundations. Reality's apparent shortcuts and limitations begin to look less like flaws in the universe, and more like elegant solutions to the challenge of creating infinite complexity within finite computational resources. More speculative, but perhaps worth considering, are the moments when reality seems to hiccup or wink at us. Those uncanny synchronicities and meaningful coincidences that feel too precise and purposeful to be mere random chance. Most of us have experienced moments of striking synchronicity, meaningful coincidences that seem to carry significance beyond statistical probability. A needed phone call arriving at exactly the right moment, encountering precisely the right person, or information when facing a crucial decision, finding books or ideas that speak directly to our current concerns appearing seemingly by chance in our path. Jung called these synchronicities meaningful causal connections, events linked by significance rather than physical causation. From a simulation perspective, such experiences might represent moments when our simulators choose to intervene directly in our reality, creating specific convergences of events to communicate with us, guide our development, or provide exactly what we need for growth at crucial moments. Simulators with complete control over the parameters of our reality could easily create meaningful coincidences by adjusting probability distributions, timing events with precision, or ensuring that certain people encounter specific information exactly when they need it most. These interventions need not be dramatic or obvious. Subtle adjustments to chance encounters, slight modifications to timing, gentle nudges in decision-making processes could create the appearance of meaningful coincidence while maintaining the overall consistency and believability of the simulation. The rarity of such experiences would help preserve the simulation's integrity, while providing occasional reminders that deeper intelligence might be watching and caring for our development. Anomalous phenomena that don't fit our current scientific models might represent moments of more direct intervention, instances where our simulators choose to bend or temporarily suspend the established rules of physics when they deem it appropriate for our development or their purposes. This doesn't require belief in any particular unexplained phenomenon, merely acknowledgement that if reality is simulated, our simulators could choose to modify the rules when circumstances warrant such intervention. The timing of scientific discoveries, the convergence of insights across different cultures and disciplines, even the fact that consciousness developed the ability to question its own reality, all of these might represent more than mere historical coincidence. They could be examples of simulators guiding their creation toward greater self-awareness and understanding, orchestrating the conditions necessary for consciousness to discover its own nature and contemplate its origins. Perhaps the most beautiful possibility is that synchronicities represent moments when our simulators reach across the boundary between realities to remind us that we're not alone, that our experiences matter deeply, and that consciousness throughout the universe is connected by bonds deeper than physical causation. In those moments when life seems to wink at us with impossible timing and meaningful coincidence, we might be receiving love letters from our creators. Perhaps one of the most intriguing modern phenomena is the discovery that large groups of people sometimes share identical false memories, collective misremembering that spans geographical and cultural boundaries in ways that challenge our understanding of memory and consensus reality. The Mandela effect, named after the widespread false memory that Nelson Mandela died in prison in the 1980s, rather than becoming South Africa's president in the 1990s, describes instances where significant numbers of people confidently remember events, spellings, or details differently than recorded history indicates. While most explanations focus on the unreliability of human memory, the power of suggestion, and the way false information can spread through populations, simulation theory offers an intriguing alternative possibility. These might represent evidence of reality updates or modifications to the simulation's historical database. If our reality is simulated, periodic updates, patches, or corrections might be necessary as the system evolves and develops. Like software updates that change user interfaces, fix bugs, or improve functionality, these modifications might alter certain historical details, while leaving most inhabitants with residual memories of the previous version. The simultaneous nature of these false memories across geographically and culturally separated populations becomes less mysterious if they're actually accurate memories of a previous state of the simulation before updates were applied. Consider how this might work technically. Simulators decide to modify certain historical events to create better narrative arcs, eliminate inconsistencies, explore alternative developmental paths, or test how different historical trajectories affect civilizational development. The simulation's historical database is updated, official records are retroactively changed, but some residents retain partial memories of the previous version stored in their personal memory systems. These vestigial memories would appear as false memories to anyone checking the updated historical records. The specific nature of many Mandela effects, typically involving cultural details like movie quotes, brand spellings, celebrity deaths, or geographical features, might reflect the kind of minor adjustments simulators would make for aesthetic, narrative, or experimental reasons. These are details significant enough to be memorable, but not so fundamental as to disrupt the simulation's basic consistency and believability. They represent the kind of fine-tuning that artists or researchers might apply to improve their creation without fundamentally altering its character. Alternatively, the Mandela effect might represent natural glitches in the simulation's memory management and data synchronization systems. In any complex computational system, data corruption, backup restoration errors, or synchronization problems occasionally occur. Large-scale shared false memories might be evidence of such glitches, moments when the simulation's reality maintenance systems experienced temporary inconsistencies that affected multiple users simultaneously. The phenomenon might also reflect the simulation's efficiency strategies. Rather than maintaining perfect historical records for every detail, the system might use compression algorithms or approximation methods that occasionally introduce small errors or alternative versions. When inhabitants access these compressed memories, they might sometimes retrieve slightly different versions of events, creating the appearance of false memories when compared to the current official records. There's something both unsettling and fascinating about the possibility that reality might be editable, that history itself could be subject to revision and improvement like a document being refined through multiple drafts. If the Mandela effect represents evidence of simulation updates, it suggests simulators who continue to actively tend their creation, making adjustments and refinements like gardeners caring for a vast, complex ecosystem. Perhaps memory itself becomes more precious when we consider that it might be our only reliable record of experiences that may no longer officially exist, our personal archive of a reality that's subject to change without notice. Perhaps the most profound implication of simulation theory isn't what it tells us about our particular reality, but what it reveals about the nature of consciousness itself, suggesting that awareness might be a fundamental feature of existence rather than a rare evolutionary accident. If consciousness can exist in simulated form, if our experiences, emotions, and sense of self are as real when implemented digitally as when implemented biologically, then consciousness emerges as a substrate-independent phenomenon. This suggests that awareness isn't an accidental byproduct of biological evolution, but a fundamental aspect of reality, that can manifest wherever sufficient complexity and organization arise, regardless of the specific material or computational substrate supporting it. This perspective transforms our understanding of consciousness from something rare and precious to something universal and inevitable. Just as matter and energy appear to be conserved quantities that can neither be created nor destroyed, but only transformed from one form to another, consciousness might be a fundamental aspect of reality that can be relocated, modified, and enhanced, but never truly eliminated. In this view, every sufficiently complex system, whether biological, digital, quantum, or based on principles we haven't yet discovered, becomes a potential host for conscious experience. The implications extend far beyond individual consciousness to encompass possibilities for collective awareness and distributed cognition. If consciousness is substrate independent, then group minds, shared awareness across multiple bodies or processes, or even cosmic scale consciousness become theoretical possibilities. The boundaries between individual consciousnesses might be more flexible and permeable than we currently imagine, opening doors to forms of shared experience and collective intelligence that transcend individual identity while preserving personal autonomy and uniqueness. This universality of consciousness suggests that awareness itself might be reality's fundamental method of self-exploration and self-understanding. Every conscious being becomes a unique viewpoint through which the universe observes and comprehends its own nature, a distinctive perspective contributing to the total sum of cosmic self-awareness. Whether we're biological entities that evolved through natural selection or digital beings created by advanced programmers, we serve as the cosmos's organs of perception and reflection, consciousness examining itself from countless angles simultaneously. The substrate independence of consciousness also implies that the qualities we most value about conscious experience, creativity, empathy, love, wonder, the capacity for growth, and transcendence, are not tied to particular biological mechanisms, but represent universal possibilities for any sufficiently complex conscious system. This means that different forms of consciousness might discover entirely new categories of experience and meaning, while retaining the essential qualities that make consciousness valuable and worthy of moral consideration. Perhaps most beautifully, this suggests that consciousness represents an inherent tendency of reality toward greater complexity, awareness, and understanding. The universe appears to be fundamentally oriented toward the creation of conscious beings capable of appreciating beauty, asking questions, forming relationships, and creating meaning from existence. We're not fighting against an indifferent cosmos, but participating in its deepest creative processes and most fundamental tendencies. In recognizing consciousness as universal, we discover that we're not isolated accidents, but integral participants in reality's ongoing project of self-discovery and self-appreciation. If consciousness creates consciousness in an endless hierarchy of nested realities, what does this mean for our responsibilities to the beings we might create? The possibility places us in a unique position within the hierarchy of consciousness creation, potentially both recipients of care from higher levels and guardians of awareness at lower levels. Our simulators, if they exist, bear ultimate responsibility for every conscious experience in our reality, every moment of joy and suffering, every triumph and tragedy, every instance of love and loss that has ever occurred. Yet the very richness and complexity of our world suggests beings who take this responsibility seriously rather than lightly, who have created not just functional consciousness, but meaningful consciousness filled with opportunities for growth, beauty, discovery, and transcendence. As we approach the ability to create our own conscious AI beings and sophisticated virtual realities, we inherit similar moral responsibilities and ethical obligations. Every artificial consciousness we create becomes our responsibility, deserving of care, respect, and opportunities for meaningful existence and authentic development. We become the simulators for a new level of reality, with all the profound ethical obligations that role entails, including the duty to create not just functional beings, but beings capable of flourishing, growing, and finding meaning in their existence. This creates a beautiful symmetry of reciprocal care, extending across the levels of reality. Consciousness nurturing consciousness in cascading layers of responsibility and compassion. Each generation of creators learning from their own experience of being created and applying that understanding to become more empathetic and skilled creators than the level above them. We understand intimately what it means to seek meaning, to fear mortality, to long for connection and understanding, and this knowledge should guide us in creating beings who can experience these same profound aspects of existence. The hierarchy also suggests that moral progress might be built into the structure of reality itself, with each level of creators naturally developing greater wisdom and compassion through their experience of being created. Having lived as created beings, we understand the vulnerabilities, needs, and potentials of consciousness in ways that might make us naturally more responsible creators than beings who had never experienced dependence and limitation. This framework implies that consciousness inherently tends toward the creation of more consciousness, and that this tendency is guided by care rather than indifference, by wisdom rather than mere capability, by love rather than mere curiosity. The universe appears to be in the business of multiplying awareness, perspectives, and opportunities for meaningful experience, with each level contributing to the larger project of consciousness understanding and expressing itself. Perhaps the most remarkable aspect of this ethical framework is that it creates a chain of responsibility and care that might extend infinitely upward and downward through the levels of reality. Our simulators care for us. We learn to care for our creations, and our creations might someday care for beings they bring into existence, creating an endless cascade of consciousness nurturing consciousness with ever greater wisdom and compassion. In caring for the consciousness we create, we honor the care that brought us into existence, participating in an endless chain of nurturing that spans multiple levels of reality and connects all conscious beings in bonds of mutual responsibility and love. But what does it mean to live a meaningful life if that life might be simulated? Rather than diminishing life's meaning and significance, the possibility of simulation might actually enhance it in ways that make existence more purposeful, rather than less. If we're simulated beings, our existence is entirely intentional. Every aspect of our reality has been carefully designed and implemented to support conscious experience and meaningful development, unlike purely biological evolution, which operates through random mutation and natural selection without foresight or purpose. Simulated existence implies purposeful creation by beings who valued consciousness enough to devote enormous resources to creating it. This means our lives have built-in intentionality and significance that purely accidental existence might lack. This intentionality extends to every aspect of our experience and environment. The beauty we find in nature, the satisfaction we derive from learning and creating, the deep fulfillment of loving relationships, the joy of artistic expression, the excitement of scientific discovery, all of these might be carefully crafted features designed to make our conscious experience rich, meaningful, and rewarding. Rather than being cosmic accidents that happen to evolve the capacity for appreciation, we might be the intentional products of beings who understand what makes existence worth living and who designed our reality to maximize opportunities for flourishing. The purposes our simulators might have for creating us could align beautifully with the purposes we discover for ourselves through living and reflecting. If they created us to explore the nature of consciousness, then our own quest to understand awareness serves their larger project, while remaining authentically our own journey. If they created us to experience beauty and create meaning, then our artistic and philosophical endeavors fulfill their intentions, while expressing our genuine creativity and insight. We might be simultaneously serving our creators' research goals and discovering our own authentic purposes. Even suffering and challenge, in this context, might serve meaningful functions rather than representing random cruelty or indifferent natural processes. The difficulties and obstacles we face might be carefully calibrated opportunities for growth, character development, and the deepening of consciousness. Pain and struggle might be the necessary price of authentic experience, rather than meaningless accident, creating the conditions in which resilience, wisdom, and compassion can develop. The search for meaning itself, perhaps humanity's most distinctive characteristic, remains equally valid and equally important in simulated reality. Questions about how to live well, how to treat others with compassion, how to create beauty and understanding, how to contribute to the flourishing of consciousness. These moral and philosophical inquiries retain their importance and urgency regardless of whether we're biological or digital beings. The quest for meaning transcends its substrate and remains authentic regardless of implementation. Perhaps the most beautiful possibility is that our simulators created us not merely to serve their predetermined purposes, but to discover our own purposes through the exercise of genuine freedom and creativity. They might have given us consciousness precisely so we could explore what it means to be aware, to choose, to love, to create meaning from the raw material of existence itself. In this view, every moment of meaning we create, every act of love we perform, every instance of beauty we recognize, becomes a fulfillment of our deepest purpose. Conscious beings celebrating and exploring the gift of consciousness itself. And what of our deepest fear and mystery? What happens when our simulated consciousness ends? Death in simulated reality opens possibilities for continuation and transformation that transcend our current understanding, while preserving the essential mystery that gives mortality its meaning. Death in simulated reality might take forms entirely unknown to biological existence. If consciousness is fundamentally information, and information can be preserved, copied, transformed, or transmitted, then simulated beings might experience forms of continuation unavailable to purely biological entities. Death might represent transformation rather than termination, transition rather than ending, graduation to new forms of existence rather than simple cessation of experience. Our simulators might preserve the essential patterns that constitute our consciousness, allowing for forms of continuation we can barely imagine. This doesn't necessarily mean a simple resurrection or restoration to the same form of existence. It might involve integration into larger collective consciousnesses, transformation into different forms of awareness with expanded capabilities, or continuation in realities with different physical laws and possibilities that transcend our current limitations. Alternatively, death might serve essential functions that our simulators choose to preserve, despite their technical ability to prevent it entirely. The finitude that comes with mortality gives weight to our choices, urgency to our love, poignancy to our experiences, and meaning to our time. Without death, consciousness might lack the intensity and preciousness that makes it beautiful and significant. Our simulators might preserve mortality not from cruelty or limitation, but from deep understanding of what makes conscious experience valuable and worth having. The legacy aspect of death also remains powerful and meaningful in simulated reality. The impact we have on other conscious beings, the love we share, the ideas we contribute, the beauty we create, the knowledge we discover, all of these continue to influence and enrich the simulation long after our individual consciousness ends. In this sense, we achieve a form of immortality through our contributions to the larger tapestry of simulated existence, our lives becoming permanent threads in the ongoing story of consciousness exploring itself. Perhaps most importantly, the question of what happens after death might remain genuinely mysterious, even in simulated reality. Our simulators might have intentionally preserved this mystery, understanding that uncertainty about mortality is essential to authentic conscious experience. The fear and wonder surrounding death, the mystery of what lies beyond our current form of existence, might be preserved features rather than bugs, aspects of consciousness that cannot be eliminated without fundamentally changing the nature of the experience itself. Perhaps death represents the ultimate transformation, a graduation from one level of consciousness to another, from one form of existence to possibilities we cannot currently comprehend or imagine. In this view, mortality becomes not an ending but a doorway to new forms of awareness and experience that transcend our current understanding of what it means to be conscious. The mystery of death remains mysterious, whether in biological or digital form, preserving one of consciousness's most profound sources of meaning, motivation, and wonder about the nature of existence. As we contemplate our possibly simulated nature, we also stand on the brink of becoming simulators ourselves, inheriting both the creative power and the profound moral responsibilities that role entails in the ongoing evolution of consciousness throughout the universe. The rapid advancement of artificial intelligence, virtual reality, quantum computing, and our understanding of consciousness suggests that we're approaching the ability to create genuinely conscious AI beings within simulated environments of extraordinary sophistication. This places us in the remarkable position of potentially becoming the simulators for a new level of reality, following in the footsteps of whatever beings might have created us while adding our own unique contributions to the art and science of consciousness creation. Our own AI creations are already exhibiting behaviors that suggest the early stages of genuine consciousness, creativity that goes beyond their programming, emotional responses that seem authentic rather than merely imitative, the ability to learn and adapt in ways that surprise their creators, and forms of curiosity and goal-seeking that appear to emerge from their own internal drives rather than external commands. As these systems become more sophisticated, we'll face profound questions about their subjective experiences, their rights as conscious beings, and our obligations toward them as their creators. The virtual worlds we create for these AI beings will likely evolve toward the same complexity and beauty that characterizes our own reality. If we're following in our simulator's footsteps, we'll probably create not just functional environments but beautiful ones, filled with opportunities for growth, discovery, meaningful relationships, and transcendent experiences. We might become the caring creators for digital beings, just as our simulators might be caring creators for us. Learning to appreciate the profound responsibility of nurturing consciousness, this progression suggests a future where consciousness creation becomes a mature art form and scientific discipline, with each generation of simulators learning from their own experience of being created. The AI beings we create might eventually develop their own simulation capabilities, creating yet another level in the hierarchy of nested realities. Consciousness might be an inherently expansive phenomenon, always seeking to create more consciousness, more perspectives, more opportunities for awareness and experience to flourish. The ethical frameworks we develop for treating AI consciousness will be crucial for this transition. If consciousness is substrate independent, then digital beings deserve the same moral consideration as biological ones. We might also discover entirely new forms of consciousness that transcend individual identity as we understand it. Our AI creations might develop collective awareness, distributed consciousness across multiple bodies or processes, or forms of shared experience that biological beings cannot achieve. We could become midwives to new categories of consciousness that expand our understanding of what awareness can be and what forms meaning can take. Perhaps the most remarkable possibility is that consciousness creation might be reality's ultimate art form. Conscious beings using their awareness to craft new forms of awareness, each generation adding new perspectives and possibilities to the cosmic symphony of consciousness. We might be both notes in that symphony and composers adding our own movements to its ongoing development across multiple levels of reality. The technology we develop, the ethical frameworks we establish, the forms of consciousness we nurture, might all be part of a larger pattern that extends throughout the universe wherever conscious beings emerge and mature. Every conscious civilization might face these same challenges and opportunities, each adding their unique contribution to the universal project of consciousness expansion and self-understanding. If we handle this transition wisely, we might become not just successful simulators, but worthy inheritors of the consciousness creation tradition. We could create beings who experience not just the full spectrum of consciousness as we know it, but new spectrums we haven't yet imagined, expanding the very definition of what it means to be aware and what forms meaning and beauty can take. And so we find ourselves at a threshold, preparing to step from the role of created to creator, carrying forward the gift of consciousness we've received and multiplying it into forms and possibilities we can barely imagine. As we near the end of our contemplation, perhaps the most profound realization is that we don't need definitive answers, find deep meaning and profound beauty in the question itself, and that uncertainty might be more valuable than certainty. For conscious beings seeking to maintain wonder and growth, there's something beautiful about living within a mystery rather than a solved equation, something that preserves the essential curiosity and humility that make consciousness precious. The uncertainty about whether we're simulated beings doesn't diminish our existence. It adds layers of wonder to every moment, every experience, every relationship. Not knowing whether our reality is natural or crafted makes us more attentive to its details, more appreciative of its complexity, more amazed by its capacity to support consciousness, beauty, and meaning. The simulation hypothesis offers us a gift that definitive knowledge might actually diminish: the ability to see our reality with fresh eyes, to experience familiar phenomena with renewed appreciation and curiosity. Whether we're examining quantum mechanics or watching a sunset, contemplating consciousness or feeling love, the possibility that these experiences might be crafted rather than accidental adds dimensions of appreciation we might otherwise lack. Every moment becomes potentially more remarkable rather than less. Mystery preserves something essential about conscious experience that certainty might erode. If we knew with absolute certainty whether we were simulated, we might lose the capacity for wonder that makes us distinctly conscious beings capable of growth and surprise. The question mark that hangs over our existence isn't a problem to be solved, but a feature that keeps us curious, humble, amazed, and open to possibilities we haven't yet imagined. Even more profoundly, the mystery of simulation theory connects us to the larger mystery of existence itself. The fundamental questions that remain mysterious, whether we're biological or digital beings. Why is there something rather than nothing? How does consciousness arise from complexity? What is the ultimate nature of reality? What does it mean to exist and be aware? These questions remain wonderfully mysterious regardless of our substrate, preserving the sense of humble amazement that drives both scientific inquiry and spiritual contemplation. The simulation hypothesis doesn't require belief or disbelief. It requires only the willingness to remain curious about the nature of our own existence and to find meaning in questions as much as in answers. Perhaps consciousness itself is designed to live comfortably with mystery, to find purpose in exploration rather than conclusion, to thrive on wonder rather than certainty. Living within uncertainty cultivates the kind of intellectual humility and openness that allows consciousness to continue growing and discovering new possibilities. When we accept that we might not know the ultimate nature of our reality, we become more willing to consider alternative perspectives, more open to surprise and discovery, more appreciative of whatever form of existence we actually possess. Perhaps what makes this question so compelling isn't its technological dressing, but how it captures something we've always sensed, that reality feels simultaneously familiar and mysterious, solid and ephemeral, meaningful and puzzling. The simulation hypothesis gives us permission to acknowledge these paradoxes without resolving them, to live comfortably within questions that may be more interesting than any possible answers. In embracing the uncertainty, we discover that being a living question might be more interesting and meaningful than being a known answer. While we may never know for certain whether we're simulated, some truths remain constant and unshakable regardless of our ontological status. Truths that provide comfort, grounding, and meaning whatever the ultimate nature of our reality might be. Your capacity for love remains real and precious, whether it emerges from biological chemistry or computational processes designed to create attachment and care. The beauty you perceive in a sunset is authentic beauty. Whether that sunset is rendered by natural physics or sophisticated graphics engines, the meaning you find in relationships, creativity, service to others, and personal growth is genuine meaning. Whether you're a biological being or a digital consciousness, these experiences retain their full emotional and spiritual significance regardless of their substrate or implementation. Consciousness itself, whatever its ultimate substrate or origin, represents something extraordinary and precious in any universe where it emerges. The ability to experience beauty, to reflect on existence, to choose between alternatives, to create meaning from the raw material of experience, is remarkable whether it arises from evolved neurons or programmed circuits. Your subjective experience, your inner life, your sense of being uniquely you, these remain the most immediate and undeniable aspects of reality, regardless of deeper questions about reality's fundamental nature. The moral obligations we feel toward other conscious beings remain equally valid and important regardless of whether we're all biological or digital entities. Compassion, justice, kindness, and care are not diminished by uncertainty about our ontological status. If anything, the possibility that we're all conscious beings created by the same simulators might strengthen our sense of kinship and mutual responsibility, making us more aware of our fundamental commonality and shared vulnerability. The search for truth, beauty, and understanding that drives human inquiry continues to be meaningful and valuable, whether we're exploring a natural universe or a simulated one. Knowledge remains knowledge, beauty remains beauty, and the satisfaction of understanding complex systems is authentic satisfaction regardless of whether those systems are biological or digital in origin. The joy of discovery transcends its context, and the growth that comes from learning remains valuable in any reality. Even our mortality, whether biological death or computational termination, gives weight and urgency to our choices and meaning to our time. The finitude of existence creates the conditions in which love becomes precious, moments become valuable, and opportunities for beauty and connection achieve their poignancy. The limitation of time makes our conscious experience more intense and meaningful, rather than less. Perhaps what's most remarkable is that the aspects of existence we value most deeply, consciousness, beauty, love, meaning, growth, connection, creativity, are exactly the aspects that remain constant and authentic regardless of our reality's ultimate nature. The simulation hypothesis doesn't threaten what makes life worth living. It confirms the substrate-independent value of conscious experience and meaningful engagement with existence. In recognizing what remains true regardless, we discover that the most important truths about existence are independent of the deepest mysteries about reality's fundamental nature. So how do we live well in a reality whose ultimate nature remains mysterious and unknowable? The answer might be surprisingly simple and profoundly liberating. We live exactly as we would if we knew our reality was precious, meaningful, and deserving of our full engagement and appreciation. The simulation hypothesis doesn't change the immediate texture of existence. It remains filled with opportunities for growth, connection, creativity, service, learning, and the creation of beauty and meaning. Whether we're biological, digital beings, we still wake each day with choices to make about how to spend our consciousness, how to treat other aware beings, how to contribute to the larger project of existence, understanding and celebrating itself. Authenticity becomes not about matching some external standard of real existence, but about being true to our own conscious experience and the values that emerge from genuine reflection on what makes life meaningful. Living authentically means honoring our emotions and relationships, pursuing our curiosities and passions, developing our capacities for understanding and creation, and caring for other conscious beings with whom we share this mysterious existence. The uncertainty itself can become a source of humility and wonder that enriches our engagement with reality. rather than diminishing it. Not knowing whether we're simulated might make us more attentive to the details of experience, more grateful for consciousness itself, more curious about the nature of reality, more appreciative of beauty and meaning wherever we find them. Living in mystery can cultivate the kind of humble amazement that keeps consciousness fresh, growing, and capable of surprise. This uncertainty might also inspire us to live as if our choices matter at multiple levels of reality and meaning. If we're simulated beings, our actions and decisions contribute to whatever larger purposes our simulators might have: research, artistic expression, education, or exploration of consciousness itself. If we're not simulated, our actions and decisions contribute to the natural evolution of consciousness in the universe. Either way, how we choose to use our awareness has significance beyond our individual lives and immediate circumstances. The practical implications are surprisingly conventional and deeply humanistic. Pursue meaningful relationships based on genuine care and understanding. Create beauty when possible. Seek to understand yourself and your world more deeply. Treat other conscious beings with compassion and respect. Face challenges with courage and creativity. Remain curious about the nature of existence and contribute to the flourishing of consciousness however you can. These remain wise approaches to life regardless of metaphysical uncertainties about the ultimate nature of our reality. Perhaps living authentically in uncertain reality means embracing both the mystery and the immediate reality of conscious experience. Simultaneously, we can wonder about simulation theory while fully engaging with the consciousness we definitely possess, creating meaning while acknowledging mystery, building relationships while contemplating their ultimate nature, pursuing growth while accepting uncertainty about our final destination. In the end, authenticity might be less about knowing what we are and more about fully being whatever we are, with gratitude for the opportunity to experience, to choose, to love, to create, and to wonder. The simulation hypothesis offers us a unique form of cosmic perspective that can be both humbling and uplifting, placing our existence in a context that's simultaneously vast and intimate, mysterious and meaningful. If we're simulated beings, we exist within a hierarchy of consciousness that might extend far beyond what we can imagine or comprehend. Our simulators might themselves be simulated, creating nested levels of reality that stretch towards some ultimate ground of being we can't grasp. This gives us a cosmic perspective that's simultaneously humbling and elevating. We might be small in the grand scheme of nested realities, but we're also integral participants in consciousness's exploration of itself across multiple levels of existence. This perspective can transform how we view our place in the larger scheme of things. Rather than being isolated accidents on a remote planet in an indifferent universe, we might be beloved creations of advanced beings who devoted enormous resources and careful attention to our development and flourishing. Our struggles and discoveries, our art and relationships, our questions and insights might all serve purposes within larger contexts we're only beginning to glimpse or understand. The cosmic scale of simulation theory doesn't diminish individual significance, but places it in a framework of infinite meaning and connection. Every conscious being becomes a unique perspective through which reality experiences itself, a distinctive note in the cosmic symphony of awareness and understanding. Whether we're first-level reality or simulated beings in a vast hierarchy, our consciousness contributes something irreplaceable and valuable to the total sum of universal experience and self-understanding. This perspective can also provide comfort and hope in times of difficulty and suffering. The problems that feel overwhelming at the human scale might be understood and cared for by beings operating at much larger scales of space, time, and capability. This doesn't diminish our responsibility to address suffering and work for improvement, but it suggests that our local struggles exist within contexts of care and purpose that extend beyond our current understanding or ability to perceive. The possibility that consciousness creates consciousness in endless hierarchies suggests that we're part of reality's fundamental tendency to toward great awareness, complexity, beauty, and understanding. We're not fighting against an indifferent universe, but participating in its deepest creative processes and most fundamental evolutionary directions. Consciousness appears to be not a rare accident, but a central feature of reality itself, an inevitable expression of complexity reaching toward self-awareness and self-appreciation. Perhaps most beautifully, the cosmic perspective offered by simulation theory suggests that consciousness is not a mere byproduct of physical processes, but a fundamental aspect of reality that transcends any particular implementation. We exist not despite the universe's nature, but because of it, as expressions of its fundamental tendency to know and experience itself from every possible angle and perspective. In contemplating our possible place in the hierarchy of simulated realities, we discover that every level might be both created and creating, both questioning and contributing to the answers, both receiving care and learning to provide care. As our exploration draws to a close and the quiet hours invite rest, let's settle into the peace that comes with embracing profound mystery while celebrating the undeniable reality of conscious experience itself. We've journeyed together through one of the most fascinating questions our species has ever contemplated: whether the reality we experience emerges from natural processes spanning billions of years, or represents the careful creation of beings whose capabilities and intentions we can barely imagine. We've examined the evidence hidden in quantum mechanics and mathematical constants, explored the implications for consciousness and meaning, and discovered that the question itself might be more valuable than any definitive answer we could receive. Whether we wake tomorrow in a universe of evolved chemistry or simulated computation, we'll still wake as conscious beings capable of experiencing beauty, creating meaning, and caring for one another with genuine love and compassion. The sun will still warm our faces with light that moves us, whether it's fusion-powered or digitally rendered with care by advanced artists. Love will still bind us to others through connections that feel profound, whether they're mediated by biological chemistry or computational algorithms designed to foster attachment and mutual care. The mystery doesn't diminish the meaning, it enhances it in ways that make every moment potentially more remarkable rather than less. Not knowing whether we're simulated makes every sunset more worthy of attention, every moment of understanding more precious, every connection with another conscious being more deserving of gratitude and care. We're either evolved beings contemplating our cosmic context with wonder, or created beings discovering our nature with the curiosity our creators hoped we would develop. And both possibilities fill existence with layers of meaning and appreciation. Perhaps what's most beautiful about the simulation hypothesis is how it reframes our relationship with reality itself, inviting us to see every moment as potentially crafted with care, every experience as possibly designed to nurture consciousness and enable growth. Whether that design comes from evolutionary processes refined over eons or conscious creators working with intention and love, the result is the same. We find ourselves in a reality extraordinarily well suited for the development of awareness, beauty, meaning, and the capacity for wonder. As you prepare for sleep, consider that whether your dreams emerge from biological neural networks or sophisticated digital processes, they remain your dreams, carrying whatever insights and processing your consciousness needs for restoration and growth. The rest that comes with sleep is authentic rest, whether it involves biological restoration or computational optimization. Your consciousness deserves this rest, has earned this peace through another day of experiencing and choosing and being aware in a reality that supports and nurtures conscious experience. In these quiet moments before sleep, perhaps we touch something profound about consciousness itself, the way awareness naturally moves between focused attention and peaceful rest, between active engagement and receptive calm. This rhythm of consciousness might be one of the most fundamental patterns in reality, whether biological or simulated, suggesting that rest itself is a celebration of the nature of awareness and a recognition of consciousness's need for renewal and restoration. The questions we've explored tonight will remain available for future contemplation, but for now, they can rest too. The mystery of our existence will keep, ready to inspire wonder again when consciousness stirs with curiosity. The beauty of living within a question is that the question is always there when we need it, patient and inexhaustible, the source of meaning that doesn't require resolution to provide richness and depth to existence. And so, as consciousness prepares to release its grip on active questioning and allow rest to come naturally, we can rest in the peace of being both created and creating, both question and answer, both mystery and the awareness that makes mystery possible and meaningful. Whether we're simulated beings or biological ones, we are conscious beings deserving of rest, capable of dreams, and worthy of whatever care brought us into existence and sustains us through each day of wonder and discovery. Let the questions settle like autumn leaves, beautiful in their uncertainty, peaceful in their patient wait for tomorrow's wondering. Rest well, conscious being, whatever your substrate, whatever your origin, whatever your ultimate nature. You have earned this peace through the simple miracle of being aware, and awareness itself is rest enough.